guys, this video is for a practice for checkpoint 4. Checkpoint 4 comes right after this video. So get out a piece of paper and do these problems along with me so that when you take your checkpoint right after this, you'll have a good set of notes to look at when you're answering those questions for a grade. So this is talking about rational and irrational numbers. So number 1 is going to ask you something about when a rational number, when you subtract a rational number minus an irrational number, what happens? So a rational number is something that either it's a decimal that repeats or terminates, or it's an integer. So let's just use for the example 5 for a second. That's a rational number. It's not something that goes on and on and on with never ending. And let's subtract something that's irrational. So how about pi? Pi is 3.14, blah, 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 blah. It goes on and on and on and on and on and never repeats, it never terminates. So if I did in my calculator 5 minus this 3.14 blah, 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 I'm going to get an answer of 2.14 blah, 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 blah. My answer is going to be irrational because I subtracted an irrational from this rational. So every time that you subtract a rational number minus an irrational number, it's always going to be irrational. Irrational. So write that down and remember, it will never be rational when you do it that way. Okay, number 2. They give you the square root of 36 minus the square root of 30. How do you properly write this answer? Okay, so we can simplify the square root of 36. That's just 6. Minus, we cannot do this. This is not a perfect square. So you can just leave it as the square root of 30. And I think if you tried to factor it, let's see, 5 times 6, which is 2 times 3, there's nothing in here that we could even pull out of that radical. So your answer would just be 6 minus the square root of 30. That's all. Don't try to do anything else. Number 3, what if you had a rational number times an irrational number? What happens then? So there could be many things. So let's use our example up here of 5 and pi again. 5 times pi. So if I type in my calculator 5 times 3.14, blah, 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 you can imagine that the number is still going to be a non-terminating decimal. It's going to keep going on and on and on and on and on because I just took this number and multiplied it by 5. I made it 5 times as big, but it's still not ever going to end. Okay, but now the question is, could you find something to multiply by to make this not be an irrational? So I know that the answer could be irrational because I just showed that here. But is there any way to make it equal a rational number? So that's what you need to figure out to answer number 3. So think about that for a minute. Is there any way to make that turn out rational? Okay. Number 4, if we have an irrational number times another irrational number, what happens there? So let's just use pi. If I had pi times pi, 3.14 repeating, or not repeating, but keep going, times another 3.14, blah, 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 blah. Guess what? It's still going to be irrational. It's going to be just this long, never-ending decimal. But now you want to think. So I know it can be irrational, but is there any way to make it rational? So I'll show you because I didn't really show you everything on number 3. But what if, so let's choose an irrational number. Like up here, we know that the square root of 30 is irrational because we can't get just a regular number out of it. So let's use the square root of 30. So if I used the square root of 30, and what if I multiply that by itself, the square root of 30? Let's just play around with this for a minute. So the square root of 30 times the square root of 30, that is the square root of 30 squared, because I multiplied by itself, right? Well, this is interesting. I have something, the square root of it squared. Those are opposite operations, so they cancel each other out. You can think of it like this also. I could rewrite the square root of 30. I could rewrite it as 30 to the 1/2 power and raise that to the 2nd power. I can rewrite it like that. And now we know when we raise a power to a power, we multiply those exponents. So this is 30 to the 1/2 times 2 is just 1. 30 to the 1st power, that's just 30. So I took an irrational number times another irrational number, and I made it rational. So this is what you need to do. Play around for a minute before you go do your checkpoint and see what can you do with these. Is there any way to make them rational, or are they always going to be irrational? So that's all there is to checkpoint 4. So use these as your notes as you take your actual checkpoint.